The arrival of applications that use video requires increased bandwidth. So we can very well increase the speed of the network by using faster links, but this solution is very expensive. It is also possible to increase the speed by using several physical links between the switches. But the spanning tree protocol will block one of the links to avoid loops. The solution that was found and developed by Cisco is the technology of the EtherChannel. This protocol makes it possible to increase the speed between the switches by grouping several fast Ethernet ports, or Gigabit Ethernet, in a single logical link, which will be called EtherChannel. On the topology on the right, the two physical links are grouped together in a single EtherChannel, which therefore solves the problem of the spanning tree, because it only sees a single EtherChannel link. It therefore no longer needs to block hard links to avoid a loop. And since all the physical links in an EtherChannel are active, this therefore increases the bandwidth. 2 to 8 physical ports can be combined into a single EtherChannel logical link. The only condition is that the types of ports must be identical on this same link. That is, for example, you can combine 4 fast Ethernet ports in a single Ethernet link. But on the other hand, it is not possible to combine 2 fast Ethernet ports and 2 Gigabit Ethernet ports in an EtherChannel. It is also possible to configure multiple EtherChannel links between 2 devices. And in this case, the spanning tree will block one of the EtherChannel's links and thus it will allow for redundancy. When the spanning tree performs the blocking, the entire EtherChannel is impacted. That is to say, it blocks all the ports belonging to this EtherChannel link. Another advantage of EtherChannel is its configuration, as it allows several physical links to be grouped together. Well, if we make changes to the EtherChannel port configuration, it will be all the ports that belong to this link, which will be configured automatically. In addition to providing redundancy, EtherChannel can also do load balancing. The goal of link aggregation is to increase bandwidth by merging multiple physical links into a single logical link. For example, if we use 3 links of 100 megas and I make a single logical link, the speed will be 300 megas. An aggregation can have a maximum of 8 physical interfaces. You will see 2 types of link aggregation protocols: PAgP and LACP. PAgP is a Cisco proprietary protocol, which uses 3 statuses in its configuration. The on status is used to declare an active aggregation. In desirable mode, it makes the request with the switch opposite to create the aggregation, and the auto status will wait for the negotiation to become an aggregation. The table shows us the compatibility with the different PAgP modes. And LACP protocol is a standard protocol that can communicate with different vendors. It also uses 3 statuses in its configuration. The on status is to declare an active aggregation. The active mode is identical to the desirable mode of PAgP, and the passive mode, which corresponds to the auto mode of PAgP. That is to say that there too, it will wait for the negotiation to become an aggregation. The compatibility of the different modes are identical to the PAgP protocol. We just have to remember that the active mode of LACP corresponds to the desirable mode of PAgP, and passive corresponds to the auto mode.